Yeah, hi. So today would like to see this problem, this coding problem, longest common subsequence. That is, these are the two input given strings, given input strings. So we need to find the what is the maximum possible substring or subsequence that can be generated, which are having common characters. For this, x. So this is the answer for this. So zx vv y zw xk yk z zpw. So x is common, y is common, and z is common, w is common. So that is the maximum sequence. So okay, how to approach this problem? So I will proceed with the dynamic programming DP approach. So we need to calculate. We need to take smaller chunks of the problem instead of taking the large part. And I will. So okay. So this is an empty string and I'm trying to create a 2D array zx v v y z w z x k y y k z p w. So this is an empty string. I just added an empty string or character, whatever you think between before the this given string. So okay, so I will compute what are the manually compute the what are the maximum subsequences, longest subsequences that can be generated, uh, taking a small parts of the problem. So what's the reason behind this? So I need to find a formula out of this, how this can be done. So empty string and empty string is there. So what is the maximum characters that can be common subsequence that can be generated? It is an empty string. So just in case, like for representing the empty string, I am representing like this forward slash forward slash. So empty string and x is there. So there is nothing common. So still it is an empty string, the common substring. So common character or what. So it will be an empty string. And similar for empty string and all the remaining characters, it will be empty string. Okay, so this is also empty string and there are characters. Empty string and z, empty string and x, empty string y, b, v, z, w. Okay, so what? So if z and x are there, so here what is present? Empty string x, empty string z, empty string z is there. So what are the common characters? There is nothing common in this by just looking at this. But what is the approach we are going here is, what is the algorithmic way here is, I will tell. So if there are two strings abc and ac, so how will you, what is the approach is, so we will take the last characters. If it is same, we will add or append to a lcs variable. So and remove that common character, and we will see if if we will see the remaining part of the strings and compare the last characters again. B and A are present, so they are different. So what will happen? So if it is different, we will try to remove one character. Either we can remove B or either we can remove A. I will try to remove A. Then it will become, the second string will become empty string, and I will place A here. So when comparing A, B and empty string, so this is an the common character is empty string. Okay, and I will place this again here because there is nothing that came out of this. So I will now remove the B and place somewhere else. So then I see their commonality A and A. So I need to place A here. So what is A empty string C? It is just AC. So ABC and AC, the common character is AC. What we did? when the characters are equal, we kept or appended to a LCS string. And if it is different, the last two characters are different, we remove one of the characters and try to compare the remaining leftover strings. That's the algorithm here, what is happening. So if zx is present, they are different. So we will try to remove one and put another one. So you can just keep uh, this is an empty string. There is no substring for this. There is no common string. See, then z and k is present. This is also an empty string. Z and y. I mean z and xky. There is no common substring. So z and k. There is no common substring. Okay. Then z and z is present. So there is common substring z and this string. So this z is a common string. So I will keep z as part, append it to the LCS, and I will check. I will remove that, and we'll see is there any character that matches. So that is empty string. The common character is, so empty string into z is z. Okay. So okay. So I will proceed with p. So empty string and z and this string ending with p. So there is no substring. Yeah, there is substring. See, z is present. So what we are actually doing is, say, x k y k z p z p, and there is starting with empty string and z. What we are doing here, we compared the two strings ending characters are different. So we will remove one character and keep some. So, and we will compare the next two characters. It seems z is present. So what here we are doing? So when I say we are removing one character, so one character, we are coming here. We're coming to this position, comparing empty string z and removing p means compare coming here, right? So z. So what I'm trying to tell is the the result of this place is, if the characters are different, it will be either this place or this place. So and w is there, w is also there. So similarly, z is either this place or this place. Which one is maximum number of the characters? Okay, so x is present. So x, if x is present, what we can do, x and x. So empty string zx. So these two characters are equal at the end. So we can append it to the LCS, least common subsequence, and we can remove this x, and z is left over. So what happened when we remove x? When we remove x from here, while calculating this value, when removing x, we are just going to the top row, and the resultant is empty string. What is present here? Empty string and empty string z, empty string and empty string z. We're just comparing this value. So we are actually appending to this. So this will become x. And x and k are different. So if it is different, so see the values one either which is bigger between these. So x, x. So there's nothing x. one here. So one thing, yeah, here one thing here is, so x and z, they both are one characters. So you can either take x or z. So I am taking x. So here, if you see v and x, they are different. So get the larger value from this or this. X, x, x. V is not there. So v is not there. So similar to above, x character and y. So if you see y, x is not equal to y, so it will be just x here, and y and k will become x, still the bigger among the this one. And oh, see, if you see y and y, they are same, then what we need to do, append the similar character to whatever is present in the diagonal element. So it will become x and y. You can just manually see why I have written this. So if you are manually calculating empty string x, k, y, empty string z, x, v, y. So as already y is present, we can append y to the LCS and remove the y part. And the remaining part is we already calculated here. This empty string. Uh, yeah, this part, empty string xk and empty string zxvv. This is exactly the diagonal part. So instead of calculating again this and between the characters among this, I am just using the diagonal element. Yeah, in this way, so we conclude that if the characters are equal, say if character, I will try to call this as LCS array, 2D array. LCS if character present in the I j is equal to character, if these are called string 1 and string 2, if this is called string 1 and string 2, so string 1, if it becomes string 1 of say I and j is equal to string 2 of some I and j, then what we can do, we can just get the appended value of the diagonal element with the, if it is equal, just what will you do? So LCS of ij is equal to append LCS of I minus 1 j minus 1, the diagonal element, plus the element which is in common. That could be string 1 of IRJ or whatever it might be. Or string 2 of IRJ is both same. Did I miss anything here, or string 1? So string 1 of, oh sorry, this is strings, this is not array. So string 1 of I is equal to string 2 of some j. Okay, so this would be string I, string 1 of I. Yeah, if it is different, what we will do? If it is different, so get the maximum value. LCS of I j will be equal to the, we need to get the longest, right? So maximum of these characters, just LCS of I minus 1 j comma LCS of I j minus 1. Which one is bigger? You, based on the length, take that. So this is the formula for this. The remaining we need not to fill because we already got the formula. Okay. Okay, so we will proceed with the time and space complexities. We can still improve this, because if you see, we are using I minus 1, j minus 1. We are just using a row which is just above this and column just above this. So we will be we will be using just these three characters for calculating this value. So it's waste of memory for storing all these values. So we can reduce the memory storage to just two rows. That is one possibility. So but initial like time complexity is big O of. So what we are doing, so we are trying to build this array which is of m is the one of the string length, and n is the string length. But what we are actually doing other thing is x and y. So x into y, we are appending mm, x to x to y. Okay, if you go further, what will happen here is xyzw. Uh, at the last moment, xyzw will appear here, which would be appended to xyz. So xyz, so xyz appended to w, appended to w. So xyzw, it will become xyzw. So this is actually not a constant time operation. Xyzw, it needs so for this, for adding the four characters, it needs big O. It is of big O of 4. If it is just two characters append, three characters appending, if it is big O of 3, it's not big O of 1. So whenever the size increases, size of the appending strings increases, the time taken for will be increasing. So this is not constant time operation, this appending. So we need to consider that uh, while calculating the time complexity. So what is happening? So XYZW, what is this? So this is the LCS, least common character. So in worst case, if the strings are like this, A, so 4A's and A, 5A's. So what would be the common string? 4A's. So 4A's, right? So what is happening? So we are, if this is m and this is n, we are taking the minimum of the minimum between these two. This is the worst case scenario, and we can tell here for appending, so it will take minimum of mn. The the space complexity would be same this, like like building the array mm, and min of m into n, because we are uh, building these x and x into y concatenations and all those. So we will go to the actual implementation of this. Say we have the def, say longest common substring, longest common subsequence, and it will take two parameters. Two parameters, so that is string 1 and string 2. So string 1 is this, string 2 is this. So what we're doing, we are initializing the array, 2D array. So what can I do is, so I will take a LCS array, which is I'm starting like this. So put empty elements or empty list in each box, and put for a length of the number of the length of the string 1. So for I in range, length of string 1, and this is one part. So we are putting this empty lists in length of the string 1 times, and you need to iterate, and you need to put that whole list string to length of the times. So here one thing here is, so we are using extra character this empty string. So if you just start with 0, it won't iterate completely, so it will leave. We need to iterate +1. This is for this. So how many lengths will happen? Length of the string times. So if the string is 1 2 3 4 5 6 7, 7 is there. mm, 7 plus 1 8. It will iterate 8 times, but the indexes would be 0 to 7. So, and just make it for, and do this part like rows. For I, for j, in range, length of string 2 plus 1, because we added the empty string here too. This is +1. Okay, so this is the initialization. So what we need to do, we need to calculate the using this formula. So how can you do that? For iterate for I in range, length of string 1. So I will, length of the string 1, start with 1 instead of 0. Why am I doing this? So we will see this. Why am I doing that? So for j in range, length of string 2. Okay, and okay, if string 1, so this is why I am doing this. So string 1 of I minus 1. So if I starts from I 1, so this will be 0. String 1 of 0 would be x. If I have given 0 here, so it will be -1, which is of. So if string 1 of I minus 1 is equal to string 2 of j minus 1, if these two characters are equal, what you will do? You will make the LCS of I j, LCS, just be LCS of I minus 1 j minus 1 plus append to the common element string 1 of I minus 1. So if it is equal, this is what. Okay, if the characters are different, so what we can do, if it is else statement, and so we got this. So get the maximum of the uh, maximum length strings. So then LCS of I comma j would become the max of LCS of I minus 1 j. I minus 1 is, so the previous row but just the same column, and LCS of I, the same row, j minus 1. So the same row but previous column. So when I'm calculating this value, so this second value is this, the first value is this, and so among these x and x, so if it is x and y is present, so based on the key, this is Python's using of the max. So we can give key is equal to len. So it will take which one is bigger and put in the LCS of ij. So we calculate up to the last part, and hmm, we can return LCS of -1 -1, the last element, this element. So this is Python's way of -1 -1, last row, last column element. Okay. So what's the thing? So what we are doing here is we are iterating length one of the string one length times, which is m, and iterating uh, into n, where n is the length of the string 2. And if you see closely, we are adding the appending every time, which is not, as we talked previously, this is not constant time operation. This is like mm, so this is because this is this is min of m comma n. Which one is smaller? So mm, it mathematically it computes to these calculations. These appendings will compute to min of mn. The space complexity is also same. We are building this array with m into n and building the concatenations. Okay, so we will see how this can be improved further. Okay, I will drop this. Okay, so space complexity is mn min of mn. Okay, so for improving this, I shouldn't concatenate this. That's what the major thing here, and I need to store some other way. Okay, so we can do similar thing like say we have this LCS two-dimensional array, and okay, so I will instantiate the two-dimensional array little bit differently now. So I will put lists but with different values. So what are the values? Yeah, I will start the coding and will let you know. So def longest common subsequence, which takes till the input of string 1 and string 2. Okay, now the LCS I will instantiate differently. Like I will take none, 0, none, comma 0. So what is this? So instead of this empty list, I'm keeping a list with these four values inside it. So what is this? So none. This place will gives the mm, previously appended result, the diagonal element, or whatever the resultant element which we are adding to the adding. So this will give the second element gives the so length of the previous result. So as we are starting initially with empty strings, so we won't be having anything appended already, so it would be of length 0, and this will give the I and j are the previous mm, what we call, so So the previous indexes. So say what I'm trying to do is I am creating lists, and every list contains these four values inside it, which will say if x, if this is x y z w is present, so we will, this would be the final empty last -1 cell xyzw, and it would be length of the 4, and go to the previous I minus 1, so it would be just length of the this it would be this I and j. So okay, I'll give this. So just similar to this, iterate for I and j. So what is the improvement which we are making? We are not concatenating. That's the improvement, and which would eliminate the min of m. Now for im range, length of the string one plus 1, and still iterate for j in range length of string 2 plus 1. This completes the initialization of the array in a different way. And okay, so do we need to do anything differently for this so far? I in range, so still 1 and the string 1 for j in range 1 to length of string 2. Okay, so if string 1 I minus 1 is equal to string 2 j minus 1. Okay, so we shouldn't concatenate now. We have to do differently using these values. If these two characters are equal, if two characters are equal, x and x is equal, so what can we do? So LCS of I j will become, if it is equal, LCS of, excuse me, okay. So this LCS is not an LCS of I minus 1. So it is a list now. So we need to keep, if it is equal, just add that this element as the first string to of I minus 1. This is of, so this is of length uh, added 1 to the previous 0. So the previous element would be LCS of I minus 1 j minus 1, because we have talked already. We can get more clarity by viewing this. Say if x is there and we calculated this as 0, this is not actually 0 in this, so 0. There are remaining characters too. So what we are doing is we are adding LCS of I minus 1 j minus 1 plus 1, because we are calculating the x, adding to the x to the element x and 1. So that's what we are doing. And what are the indices? Indices would be mm, I minus 1 j minus 1, I minus 1 j minus 1. So these will be used for mm, building the sequence afterwards. Okay, so this is okay. So I will run this. This is when the characters are equal. Okay, so if else the characters are not equal, so how will you proceed this? So x is there and y is there. So then LCS of I j will become, so as we talked, hmm, the maximum of the characters. So this would be a cell. The maximum characters would be, the first element would not be anything, because we are not adding anything x or y to the new cell, so it would be still none. And will there be any increment in the um, okay, so one thing, so if there are if the characters are different, so there are two possibilities, that okay, if x and y is present, say y is present, so we need to see this as two ways, two conditions. If LCS of I minus 1 is I minus 1 j, LCS of I minus 1 j of 1. So what I am doing, I am calculating this value. So I am comparing this value. If this LCS of I minus 1 j of 0, the first index element, is greater than, so greater than LCS of greater than LCS of I in the same row and j minus 1. I'm comparing again the first index element. Why am I comparing the first index element? Because it contains the length of the length of the string up to the previous calculations. Okay, so if this is bigger, so what we will do? So LCS of ij becomes, we have nothing to add, so the first will be none, and second will be, so will there be any um, increase in the characters? No, we will still be getting LCS of, if this is bigger, just keep LCS the bigger one, LCS of I minus 1 j 1. And what are the indices we got? I minus 1 and j. That's what the indices we got. Else is if this is not bigger. So LCS of I j, still it is none, and LCS of I j minus 1 1, in the same row, I is same row, but we are shifting to the right in the previous column, and the indices would be similar to this, I j minus 1. So this is the case when the characters are different. Okay, So there is little bit present here. So we are trying to return a sequence, but we got just these mm, just these lists present in the each individual cell. So we need to iterate or backtrack from the last final -1 cell to the uh, until we reach the none value, the first top value. So return, say I will call something like sequence, return sequence, or build sequence. Build sequence is a function which I will write shortly. Build sequence, what it will take, so it will take the LCS, the input two-dimensional array. Okay, this will return, and there is a def. We will call this build sequence, which takes this LCS. Okay, and what we can do, we will return a sequence and start initialize with an empty list. We need to return this sequence after appending all those. Okay, so how to proceed further? So we have initialized the sequence, and uh, we can initialize the last element, the last column, like this. So I and j index, say I is equal to LCS, length of, so length of LCS -1. What will it give? So it will give the last index, last index, last last column. I is equal to LC length of L minus length of LCS -1. And how will you just say about J index, where to start? So it would be length of LCS, so length of, take the first character of this cell, whatever is present. I mean this cell LCS of 0, that would be the first cell length, -1. Okay, so we initialized the j is equal to length of LCS of 0th first row length -1. Okay, so we need to iterate or backtrack while I not equal to 0 and j not equal to 0. So we need to keep like this. So current value. So what is the current value? LCS of I z, that is, say xy zw, that's the last value. And if current value of 0 is none, so current value, if it became none, the first element, so we have initialized like this. So none 0, none 0. So I am talking about this. So in current value we have taken this entire value which is present at the last -1, and I'm checking, okay, if this first 0th element, if it is none, so what to do? So if it is not none, if it is none, we need not to do anything, we need not to iterate. If it is none, so then append to the sequence dot. So one thing, so this value contains uh, just xw, not xyzw, because we are just storing the characters instead of concatenations. So just one point to clarify. So sequence dot append. When what will you append? We will append the current value, current value and zeroth. This we will append this. Okay, we have appended. And for going backtracking, so we need to iterate the I and j index. How will you identify the I and j? I and j is the I is the current value. We have got those values here as I and jth index. So just current value of this is of index 0, 1, 2, 3. So I is equal to current value of I, or it's 2. J is equal to current value of 3, the jth index. So and we will update this. And finally I think this is done. So we need to return here, return here the this part will create a string, so we need to make it to list. And to specify it is present in the reverse order. So if you want, it will give w z y x. So we need to make initially that is reversed the sequence, and need to return that. And finally this will become a string which is required in the answer. So yeah, this is an improvement over the previous one. And this time complexity is bigger of, it is iterating still m into n times, but not storing any, not concatenating anything. So it will work in the time complexity of bigger of mn, and the space complexity of bigger of mn, because we are not introducing any concatenation time complexity. So yeah, I think that's it